Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss the second type of propagation, which is called skywave propagation. In skywave propagation, the transmitted signal travels into the upper atmosphere where it is bent or reflected back to Earth. This bending or reflection of the signal takes place due to the presence of a layer called as ionosphere in the upper atmosphere. So as we can see in this particular diagram, this is the transmitting antenna and it is transmitting electromagnetic waves which are reaching up to something called as E layer, which is part of nothing but ionosphere, and it is coming back to the Earth. It may also happen that some wave may just cross the ionosphere and never comes back. But most of the waves will reflect back to Earth from this ionosphere. It is not single layer, but it forms of different layers, which we will discuss in some time. The layers of ionosphere are the principle of skywave propagation, which is as illustrated in this particular figure. So now let's discuss what is this ionosphere and its layers, because the knowledge of ionosphere and its layers will also help us to understand the skywave propagation to a great extent. So the ultraviolet radiation from the sun will ionize the upper layer of atmosphere. Due to ionization, this part of the atmosphere becomes electrically charged. The atoms take an extra electron or lose one to become negative or positive ions respectively. The free electrons are also present, and this layer of ions is nothing but known as ionosphere. It's a thick but invisible layer, and as we can see, it is represented in the form of its own various layers in this particular figure. So some important points about ionosphere are that along with the ultraviolet radiation, the alpha, beta and gamma radiations from the sun and the cosmic rays are also responsible for the ionization and therefore in formation of the ionosphere. So ultraviolet radiation is one type of radiation, but along with them alpha, beta and gamma radiation and also cosmic rays are responsible for the formation of ionosphere. So basically how does that take place? It is nothing but the collection of ions. Ion is formed when an atom either takes an extra electron or loses one electron, and accordingly there will be positive as well as negatively charged ions. There are four main ionospheric layers. These layers are called F2, F1, E and D. These are the four layers which we also shown in this particular figure in that particular order. With the heights as we have shown in this figure, F2 lies at the maximum height, then F1, E, and the very first layer is layer D, which is at the lowest height. The F1 and F2 layers recombine at night to form only one layer. So basically night time there will be only three layers. F layer, which will be combination of F1, F2, E and D. But in daytime there will be differentiation between two layers in the form of F1 and F2. Let's talk about the very first layer, which is layer D. It is the lowest and hence it exists at a height of about 70 km from the Earth's surface. It is its average thickness is about 10 km. The D layer disappears at night due to recombination. So at night time, due to recombination, the layer D will disappear. The next layer is E layer, existing at an approximate height of 100 km from Earth's surface. The thickness of D layer was approximately 10 km. The thickness of E layer is approximately 25 km. The E layer also almost disappears at night due to the recombination of ions and molecules. This happens due to the absence of radiation from the sunlight at night time. So at night time, the major factor which gives rise to the formation of the ionosphere, which is the ultraviolet radiation, are absent, and hence the formation of ionosphere depends only upon the other radiation. So D and E layers, they vanish at night time. The sporadic E layer, which is also sometimes called ES, it's sporadic E layer, is a thin but high density layer which sometimes appears with E layer. This layer we have not shown in this particular figure, but when it appears, it remains present during the night as well. It is an abnormal ionospheric disturbance. The actual and virtual heights of this layer are same. This is because it's a very thin and high density layer, the sporadic E layer. So actual reflection will always take place from this particular layer. Because it is very thick, the reflection of electromagnetic waves will take place from this particular layer. The sporadic E layer prevents the long distance high frequency communication, because it will not allow the electromagnetic waves to go to higher heights of ionosphere layers and then reflect back to the earth. Because if the reflection takes place from higher heights, then the distance covered will be also larger.